Welcome to section 1.3. So we're not covering objective 5. Let's look at example 1. Translate the following phrases into expressions with mathematical symbols. Use X for the number. Alright, so one thing to remember is that math is basically just another language. It's a shorthand way of writing what we mean, let's say in English, in symbols. So just like how maybe you text using shorthand or symbols and something, math is just using symbols for language. So let's take a look at the first one. 6 more than a number. Okay, well we know that we're supposed to let a number be x. So this is going to be x. 6 is already math. What does more than mean? Well, more than in math means addition. So this is 6 plus x. Or you could write x plus 6. Let's look at the next one. The sum of 5 and a number. We know that a number is x. And we want the sum. What is the sum? Well, the sum is addition in math. And then we already have 5. So this is just saying the addition of 5 and a number, which is 5 plus x or x plus 5. Either way works. One thing to note, with addition, it's commutative. What does that mean? Well, it means you can rewrite it. It doesn't matter which one is first. Subtraction is not, so you cannot just rewrite things with subtraction. Let's take a look at C. 2 less than a number. Okay, well we know a number is x. 2 is already a math symbol, that's 2. What does less than mean? 2 less than a number. I have two thoughts. It's either x minus 2 or it's 2 minus x. Which one do you think it is? Let's translate this into something else. Let's say you have 14 pairs of shoes, right? And I have 2 less than you. So 2 less than you, and you have 14. How many do I have? Well, 2 less than 14 is 12, right? How did I get that? Well, I took that 14 and I subtracted it by 2. So that means I'm going to do x minus 2 as my answer, because I have 2 less than that value. So you'll notice the less than, it does throw students off a lot of the time, so I like to think of examples in the real world where I can apply it, and it helps my brain sort of figure it out a little better. Let's take a look at D, the difference of a number and 3. So we want the difference between what? A number, which we know is x, and 3. What does difference mean? Well, difference means subtraction. So we want the subtraction between these two numbers. And whichever one is listed first, that is the one you'll be subtracting from. So x minus 3. Let me go ahead and box these answers real quick. Forgot to box them. Okay, let's take a look at the next one. 16 times a number. Well, we already know as usual that a number is x, and times is multiplication. 16 is already math, so this is 16 times x, or 16x. Next one, 2 plus 2 times a number. Ooh, this is a lot more going on. Well, a number we already know is x. 2 times a number, well, it's just going to be 2 times x, and then we're adding 4 to it. Okay, so 2 ways you could write 4 plus 2x or 2x plus 4. Because addition as usual is commutative. Okay, next one, 3 less than a number squared. Well, we know that less than is that subtraction meaning, right? So we're going to take 3 away from a number, but what's happened to that number? It's being squared. So we have a number squared, and we're taking 3 away from it. That one's definitely a little tricky. Next one, the product of a number and 3. Well, once again, always find that number, so that's x, and we want the product. What does product mean? Product means multiplication. So the product between a number and 3, well, that's just going to be 3x. And lastly, the quotient of a number, or of 8 and a number. A number as usual, that's x. 8 is already a math term, and we're taking the quotient. Ooh, what does quotient mean? That means division or fraction. So in this one, careful, division is not commutative. 8 over x is not the same. as x over 8. So whichever one comes first will be the one on top, which means that this is going to be 8 divided by x. Alright, let's take a look at example 2. The length of a rectangle is 2 feet more than twice the width. The perimeter is 34 feet. To find the length and the width of the rectangle, be sure to use a let statement or draw a diagram when introducing a variable. So as usual, whenever you do word problems, you need a let statement, your equation, solving, and then a sentence. So let's get a visual here. We're talking about a rectangle, right? I always find that drawing things out really helps me think about the math. So let's see, the rectangle is 2 feet more than twice the width. So the length, if this is the length, what is it? It's 2 feet more, so 2 feet more than, so that's going to be 2 plus what? Twice the width. Well, twice means timesing it by 2. Twice the width. Okay, well, do we know what the width is? No, so I'm going to go ahead and label the width as W. So if you draw a diagram and you label it with your variables, you don't need to actually write out the words let. But if you don't have a diagram, you do need to write let x equal and so on. So, okay, let's see this again. So we have the width, we called it W, and then we know the length is going to be 2 more than twice the width. And there we go. Okay, so we've labeled this. Now what are we trying to figure out? We're trying to find the length and the width. Well, we have to have some other information we can use to figure this out. And we're told that the perimeter is 34 feet. Let's think about this on the side. We know that the perimeter is 34 feet. What is the perimeter usually for a rectangle? Well, it's just if we add up all the sides, right? So if I add up all of the sides, I'll find out that they should equal 34 feet. Let's go ahead and label all the sides. So that's 2 plus 2w, and that's also w. So I'm going to go ahead and add these all up, and I know from the word problem that all these values should end up equaling 34. So I'll go ahead and write that out. 34 should equal this side plus this side plus this side plus the last side. You could do a shorthand with the formula, but I just like writing out all the sides. So we have 34 equals, well, adding up the w's, we get 2w plus, and I can go ahead and drop those parentheses. And then let's go ahead and add up the other w's. 2, 4, 6 w's. Alright, let's see. To solve for w, subtract 4 from both sides. We get 30 equals 6w. And lastly, okay, we're almost done for solving for w. 6 is being multiplied to that w. How do I undo multiplication? I'll divide by 6, divide by 6. 30 divided by 6 is 5. So 5 equals w. One thing to note again when solving work, notice I try to keep my equal signs as lined up as possible. So make sure to always do that. You know, if you can't now or then, that's okay. But keeping your work neat is one of the main things I've noticed with students that do well in math, is if their work is organized, that you know what's happening. And also it just helps me when grading, which makes me very happy when I have nice work to grade. So thank you ahead of time. Alright, last thing, what are we missing? Yep, we're missing a sentence. Okay, so we're going to write a sentence. Let's see, what are we talking about? We want the length and the width. Oh dear, wait, we only have the width. How do we find the length? Well, we can use this formula here. So I'm going to go ahead and write out what I'm doing. Finding finding L. L is equal to 2 plus 2 times W. We already found out that W is equal to 5. So go ahead, 2 plus 2 times 5. L is going to equal 2 plus 2 times 5 is 10. L equals 12. Alright, but we still need to write our sentence. So we can say the length is 12. And do we have any measurements here? I mean, any units? We do, it's feet. We're talking about feet. Length is 12 feet, and the width is 5 feet. Okay, last example for this. Oh, not last example, close to last. Sharon received a $20,000 inheritance from her grandfather. She invested some of the money in an account earning 3% annual interest and the remaining amount in an account earning 2.5% annual interest. If the total annual interest earned is $575, how much is invested at each rate? Okay, so I would call this an investment problem. Why? Well, she's investing money. Usually I use a certain box setup for this problem. You don't have to use it, but I find it really helps me organize my information. Okay, so we're talking about two different things, right? So we have, let me just go ahead and draw in these things. We have that she is doing 3% annual interest and 2.5% annual interest. So I'm going to call this interest 1, interest 2. And the formula we use for interest problems is interest equals the principal times the rate times the time. You don't need to write it out that big. I do just to fit the box. Okay, so I'm going to go ahead and draw this box in. And I'll put the time box really small. Why? Because in this class, time is always 1 year. Notice we're talking about annual interest. So I'll just go ahead and plop that 1 in. Next, I'm going to fill in all the other information that I know. So what do I know? Well, she earned 3% annual interest in one of the investments. So I'll go ahead and put that with investment 1. And that is the rate, so 3%. The next one we have was 2.5%. So I'll go ahead and put that in the other one. Doesn't matter which one you assign to yet. Let's see, what else do we know? Well, she received $20,000. And the investment she got in the end was $575. So the principal is the amount she puts in, right? So if in the first bank she puts in some unknown amount, right? Let's call that X. We don't know how much she put in. How much did she put in the other investment amount? We don't know the exact amount, but we know that it's 20,000 minus however much she put in the other one. So 20,000, take away however much she put in the one above. And that's how much we have. So these are all the boxes we filled out. So we're going to go ahead and fill in the last one, where interest is equal to principal times the rate times the time. So that'll be X times, we have to be careful. We can't use percents in a word problem. Change to either decimal or fractions. I'll go ahead with the fraction, 3 over 100. And then we'll go ahead and do the same thing for this one. Principal times the rate times the time. So that'll be 2.5 over 100 times, squishing this in, 20,000 minus X. All right. The last box you fill in is basically always going to be the one that you're going to use to write your equation. So this is the last one we filled in. And what information have we not used yet? We've used this, this, and this. We just haven't used her total interest. Well, we can use that. Why? Because this is the interest from the first one, and that is the interest from the second one. So we know that interest 1 plus the interest from the second account should end up equaling $575. Well, the interest from the first one is X times 3 over 100. Plus, and the interest from the second one is 2.5 over 100 times 20,000 minus X. Oop, my equal signs aren't lining up that well, but that's alright as long as it's basically in a line. Okay, so solving this, I want to get rid of those hundreds. So I'm going to go ahead and multiply both sides of my equation by 100 to cancel those out. That 100 gets sent to each of my different factors. There are only 2. And cancels out with each of them. So I'm left with 3x plus 2.5 times 20,000 minus x equals 575. There we go. Okay, let's see. Well, let's keep solving. We're going to get rid of those parentheses there. So multiplying that out, we'll have 3x plus 50,000. We multiply the 2.5 times the 20 minus 2.5x equals 7,500. Okay, let's keep solving. I'm going to go ahead and move up here. Make sure to use your arrowhead if you're moving directions. Okay, let's combine the x values, so the 3x and the negative 2.5x, which will give me 0.5x plus the 50,000 equals 57,500. We're solving for x. and this is a linear equation because we have x to the first power. So to do that, we'll set the x to one side and the numbers on the other. Let's go ahead, minus the 50,000 from both sides. And we have 0.5x equals 7,500. We're almost there. Okay, so one thing to remember, which I may have accidentally said calculator, but we're not allowed to use calculators for the Math 82 exams. You won't be allowed to use one on the final. So we have to make sure to do these by hand. I don't like decimals as much, so I'm going to change that to a fraction. So 0.5 is the same as a half. That equals 7,500. So I'm going to go ahead and multiply both sides by the opposite of a half, which is 2. Multiplying both sides by 2, that'll cancel out. We're left with x equals 2 times 7,500. So we got to do some scratch work here. Let me go ahead. I don't have a ton of room, but let's see, scratch work. I'll do it on the side over here. Labeling it scratch work and boxing it off. So I have 7,500 times 2. Okay, so first off, doing the 2 times the 0, that'll be 0. 2 times the other 0 is also 0. 2 times the 5 is 10. I'll go ahead and carry that 1 and write down the 0 for 10. And then 2 times the 7 is 14, plus that remaining 1, so that's 15. So we have 15,000. Once again, make sure you can do your work by hand and show your work by hand on the exams. Okay, so that is the x value for I2. Okay, so that's for I1. X is I1, so the interest at 3%. But I want the interest at 2%. So the interest at 2%, let's go ahead and write that down. Interest at 2% is going to be 20,000, sorry, minus the 15,000, which is 5,000. Okay, let's go ahead and write our statement. So, she invested $15,000 at 3% and $5,000 at 2.5%. And that is it. We're done. Example 4. How many liters of a 20% acid solution must be mixed with 5 liters of a 30% acid solution to make a 24% acid solution? Whew, got a lot going on. As usual, if I can draw a picture, I will draw a picture. So whenever I hear a mixture problem, I like to draw the picture of the mixing values. So what are we doing? We have 20% and mixing that with a 5%, and we're ending up with some other value. So we're just mixing 2 items to get an outcome, right? So whenever I do this, I like to label the percent and the quantity, and then you multiply them together. So for the first value, we have a 20% solution, right? And we want to mix that with a 30% solution, and our hope is to end up with a 24% solution. Not bad so far. So the question is, how much is the quantity for each of these? Well, for the 20%, we don't know. We were asking how many. Well, we'll let that be our variable x. If we don't know it, that'll be our variable. A great rule of thumb for that. And the 30%, how much do we have for 30%? Well, we're told we have 5 liters. And lastly, we don't know how much we should have in the end. Well, that's okay. It's going to be 5 plus however many liters we put in for x. So that'll be x plus 5 liters. Okay, and right there we can just pull from that our equation. So we'll have the 20% times the x, the 30% times the 5, equal to the 24% times the x plus 5. But we can't have percentages in equations, so we either have to write a decimal or a fraction, and I tend to like the fractions. Times the 5 equals 24 over 100 times the x plus 5. Okay, so now I want to get rid of the fractions. Go ahead, multiply both sides by 100 to get rid of those hundreds. That will distribute in to each of the separate terms. When I do that, the hundreds will cancel. And I have 20x plus 30 times 5 equals 24. Ooh, those hundreds cancel. Times x plus 5. Okay, that equation looks way better. Let's go ahead and get rid of those parentheses, multiplying in that 24 to both the x and the 5. 20x plus, and I'll multiply these together, so 30 times 5, that is going to be 150, equals, so 24x plus 24 times 5. Let me rewrite that. I don't like using x when I already have a variable x in my equation. What is 24 times 5? Oops, that should be a 24. 24 times 5, well, 5 times 4 is 20. 5 times 2 is 10, plus that extra 2 is 120. If you ever need any help with the multiplication or division handwork, please let me know. I can send you some scratch work for that or any practice problems, or just drop by the office hours. Alright, we're almost there. Get the x on one side and the numbers on the other. I'll go ahead and subtract the 20x. Continuing to solve my work on the side. I'll minus 120 from both sides to get the 4x by itself. We're almost there. 4x. How do we get rid of that 4 by the x? We'll divide by 4. And 30 divided by 4. Well, let's go ahead and figure that out. We could either simplify it in a fraction, or we can do the decimal approach. I'm pretty much fine with a simplified fraction, so you don't need to find the decimal if you don't want to. I know that both of these are divisible by 2, so 4 divided by 2 is 2. 30 divided by 2 is 15. So 15 over 2 equals x. You could stop there, or you could find the decimal. So here's my scratch work for my decimal. Please always write SW if you don't want that work to be graded. So how many times does 2 go into 15? Well, I know 2 times 7 is 14, with a remainder of 1. So my answer will be 7.5 or 7.5. These could also be your answers. But again, I am fine with an improper, fully simplified fraction. So my sentence, let's see. We need 7.5 what? 7.5 liters of the 20% acid solution. Period. Okay, that is it for section 1.3. Again, if you need any help or any further explanation on any of the problems in these lectures, always feel free to stop by my office hours or set up another office hour.